Okay, in this problem we have an indefinite integral to evaluate. So we're going to try to do some u-substitution here. We don't really have too many options. So we could let u equal x, which is never going to help us, or we could try u is equal to x plus 3. So let's try that. U is equal to x plus 3, and that would make du equal to dx. All right, so let's substitute this in. We have an x plus 3, that becomes our u, and our dx becomes our du. Now, what about this guy right here? What about the x? Well, we could go back up here to this original choice of our substitution. If u is equal to x plus 3, then we could solve for x. So subtract 3 from both sides, and that tells us that x is equal to u minus 3. Okay, so that means this x right here, that will become a u minus 3. All right, so let's rewrite our integral with our new change of variable. We have the x becomes, not plus, x becomes u minus 3. And then we have the square root of u, or let's say u to the 1/2 power du. All right, now we could apply the power rule for integration, or with the reverse power rule, if you want to call it that, by distributing that u to the 1/2. So we could split up this product. So we'll have the indefinite integral of u to the power 3/2 minus 3 times u to the power 1/2 du. Okay, so we can apply now the power rule for integration. And let's come back down here. So that should equal 2/5 u to the power 5/2, and minus, well, we got a 3 times 2/3 u to the power 3/2, and plus c, but we'll just add the plus c, the constant of integration at the end. All right, so let's see what we could do with this. Well, right here, let's just call that a 2. All right, so we have 2/5 u to the 5/2 minus 2u to the 3/2. That looks like we could factor out a u here. So let's factor out u to the power 3/2. And let's see what we're left with. Looks like we have a 2/5. So from this term here, we have a 2/5 u to the first power. And here we'll be left with a 2. So 2/5 u minus a 2. Okay, that's about all we could do for now. So now remember, this substitution, this change of variable is just temporary. So now we could take the x plus 3 and replace it back in wherever we see a u. Okay, so I'll switch colors because we're switching back variables. So now we're at x plus 3 to the power 3/2, so that's this first term, times, we have 2/5 x plus 3, and we have a minus 2. All right, now at this point, let's do a little simplifying if possible. I'm focusing in on this part here. Let's see what we could do. Okay, so we still have this x plus 3 to the power 3/2. And then, all right, let's multiply through the 2/5. Okay, so that'll give us 2/5 x plus 2/5 times 3, so that will be 6/5, and then we still have this minus 2. Okay, so now we can combine like terms. We have two numbers in there, so let's see, we have an x plus 3 to the power 3/2 times 2/5 x and 6/5 minus 2, or 6/5 minus 10 over 5 should be a minus 4 over 5. All right. We could stop here. Maybe we could go one more step, and we have this over 5, this 1/5 factor, 2 of them in front of the x, and then we have 4 of them over here, so we could factor that out, and that should probably be our last step. So we could say x plus 3 to the power of 3 over 2. Factor out a 2/5, and we're left with an x minus 2, and let's clean that up just a little bit. So our final answer should be, so let's say the integral of x times the square root of x plus 3 dx should equal 2/5 times x plus 3 to the power of 3 over 2 times x minus 2, and don't forget the constant of integration, plus c. And let's do a little circling here, and that about does it for this problem.